the previous videos, we discussed how to find the area of the triangle in terms of the determinants. And my dear students, in today's class, I am going to discuss minors and cofactors of an element in a determinant. So, if any determinant given to you, so how to find the minors and cofactors, that we are going to discuss. So, what is the use of this? That I will discuss after this session. I mean, after this class, I am going to discuss why should we study this minors and cofactors. Clear? And don't worry about this, because by hearing the words you may get confused or you may worried. So please don't worry, because already we used the minors and cofactors. That the process we used, but we didn't named it as minors and cofactors. But we already used this process. So now I'll discuss. So my dear students, minor means what? Minor means, here it is. So if I wanted to, first I'll dictate the definition. So what is the definition then? The definition of minor is nothing but, here it is. So minor of Aij in determinant. The minor of Aij means what? It is the one element I am considering here. It is. So minor of Aij in a determinant is a determinant. It is a determinant. It is a determinant obtained by deleting. By, here it is, by deleting ith row and jth column. Clear? So here my dear students, minor of Aij. So Aij is a one element in a determinant. So in a given determinant, I will consider one element. So if I wanted to find the minor of Aij in a determinant, it is a determinant. So obtained by deleting, here it is, ith row and jth column. It means where Aij is lying, that corresponding row and column, after deleting that, whatever the value of determinant, whatever the elements remaining, so that elements determinant if you consider, that we can call it as the minor of Aij. So minor of Aij means what? It is the one determinant obtained by deleting the ith row and jth column where Aij lies. That we can call it as the minor, and it is denoted by, so how will we denote? So it is denoted by Mij. So Mij means what? It is minor of ith row and jth column. So my dear students, first I will consider, here it is. For example, I will take here this. One example I am going to take here this. So example I am going to take here. So one determinant I will consider, here it is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this determinant, if I wanted to find the minor of the element 1, so here I can write here this, my dear students, minor of an element, here we can take 2. So if I wanted to find the minor of this element, so minor of this element, what is that? So minor of this element is equals to, my distance. So where 2 is the element 2, where it lies in the first row and second column, here it is lying. So now if I wanted to find the minor of element 2, so minor of 2 means what? So minor of 2 can be calculated by deleting this row and this column. So after deleting, what here it is, after deleting the row and the column, so where the element 2 lies, so the element 2 where lies in the determinant, that row and that column we should delete. And after deleting this row and this column, what is remaining, my students? Here it is 4, 6, 7, 9. 4, 6, 7, 9. Then we should consider determinant of this. And usually we know this, how to find out the determinant. How to find out determinant of order 2 cross 2? So we should multiply this element into this element. So here it is 4 9s are. So 9 for the 36 minus 42. So how much it is? So 42 minus 6, 36 means here it is 4 plus 2, 6 here it is. Clear? And here it is minus 6. So minus 6 is the minor of the element 2. Like this you should calculate. Clear? So what is the minor of the any given element, my students? So minor of the any element you can consider. So here it is definition. What is the definition I given to you? So minor of aij in a determinant. In a determinant, if any element if you consider means, so aij in a determinant is a determinant obtained by deleting ith row and jth column. It means so whose element minor you require, that element where it is present, that row and that column we should delete. And next we should consider the remaining elements. Here this determinant value we should consider, that remaining value is itself the minor of the given element. Clear? So this we used in while discussing the while calculating the determinant of order 3. Clear? And next, my dear students, I am going to discuss what is mean by coefficient of. So next concept I am going to discuss is coefficient. So coefficient means here it is coefficient. I will discuss now. So coefficient of here it is. Sorry, it's a cofactor. So here it is cofactor of an element aij. So cofactor of an element aij in a determinant. So how to calculate the cofactor? Cofactor of an element aij in a determinant. Now in this I am considering the same example. Now my dear students, so the cofactor of an element aij in a determinant, and please remember the cofactor of an element aij in a determinant. So the cofactor is you denote it by like this aij. We will denote it by the capital letter aij, a subscript ij. A subscript ij means what it indicates? Cofactor of the element of the ith row and jth column. So now in this case, my dear students, cofactor is calculated. So this is nothing but aij is nothing but means cofactor of the ith row and jth column element is equals to here it is minus 1 whole to the power I plus j. So what is the subscript you have? That minus 1 whole to the power I plus j into mij. So what is mij? Where here it is I am going to write where mij is nothing but the here it is minor of the element. So where mij is minor. Mij is minor of aij. So if you consider any element aij, then mij is nothing but the minor of the aij. So this is the cofactor of the any element aij in a given determinant. Clear? So now it's very clear to you. So if I wanted to find the cofactor of any element, so what is the value I required? First we should find the minor of that element, and then minus 1 whole to the power, so I plus j. It means the whose element cofactor you require, that element row and column you should know, and that value minus 1 whole to the power row plus column you should add, and into minor of that element. If you calculate this, then that is the cofactor of the any element aij you can consider. So now my dear students, to understand you more clearly, I will consider again this element, this example. So in the same example, now if I wanted to calculate here it is. So if I wanted to calculate cofactor of 2 here. So cofactor of 2. It means I require the cofactor of this element 2. So cofactor of this element 2 means what is the formula I had? So cofactor of 2 is equals to, I am writing here, it is cofactor of 2. So 2 means it is, how can I write this element is in the place of, here it is first row. So this is nothing but here it is a first row and second column element is 2. So if I wanted to find the cofactor of 2 means cofactor of 2 can be generally in terms of the generally I can write it as it is the A12 element. Am I clear? It is A12 element because first row second column element is 2. So but I require the cofactor of 2. So cofactor of 2 means it is nothing but cofactor of A12. Clear? So if I wanted to find the cofactor of A12 means, so here it is, or else I'll write here it is. It is cofactor of 2 means what I should find? Cofactor of 2 means it is nothing but cofactor of A12. It means that in the place of A12 element it is 2. So therefore cofactor of A12. So I am writing. So both are same meaning. Here I used in this example I used the element. What it is? 2 I used. But it is 2 is nothing but cofactor of A12 plus element is itself 2. So therefore I am taking here it is cofactor of A12. So cofactor of A12 is equals to, so here it is also I can denote here it is A12 because this is the notation. Clear? So A12 I am writing here it is. So A12 is equals to, what is the formula we have? So here it is minus 1 whole to the power I plus j. I value is 1 plus j value is 2 into mij. So mij means what? Mij means, so here it is mij. Ij here it is 1 2 m12. So therefore this is equals to minus 1 whole to the power 2 plus 1 is 3 and m12. M12 means here it is nothing but here it is minor of an element 2. It is nothing but here it is m12. Clear? So therefore m12 I calculated already. What is that? Minus 6 into minus 6. So now simplify this. This will give you minus 1 whole to the power 3 is minus 1 into minus 6. So minus 1 into minus 6 is plus 6. So plus 6 is the cofactor of 2. So cofactor of A12 element is plus 6. Like this you should calculate the cofactor and minus. Clear? And I think now you may remember. So while calculating the determinant we used this process only. Am I correct? So after next while solving the question we will come to know more clearly. So please remember, while calculating the determinant of the order 2 we used this process. I mean directly I used it, but now I am naming here this. This is cofactor and here this definition. Clear? So this is the example to understand. This will help you to understand the cofactor and minus. Clear? And next we will discuss. I will take one example and then clearly we will come to know. Clear? So yes, my dear students, just I taken one example. It's one determinant I considered here this, and here they given to you. Find minus and cofactors of the elements A11, A12, A13 in the determinant. So this is the one determinant I considered. Here we should find out the minus and cofactors. So my dear students, first I will find out the minus here this. So how to find the minus? So first what they asked, find the minus and cofactors of the elements A11, A12, A13. So first I will find out, here it is minor of Aij. It means just I am writing the formula. So minor of Aij. If we have any element here it is, so I will write clearly. So minor of an element Aij. If I have the any one element Aij in the determinant, so minor of an element Aij in a determinant is denoted like this, Mij. So Mij is equals to, how to write here it is, Mij can be written as deleting the, here it is deleting A11, here it is the deleting here. If I wanted to find the Aij means I should delete the ith row and here it is jth column, and I should take the determinant of the remaining elements. Determinant I should consider. So here it is first minor of an element Aij in a determinant is a determinant obtained by deleting, here it is, by deleting ith row and jth column. Here minor of an element aij in determinant is a determinant obtained by deleting ith row and jth column. It means here it is, if I wanted to find the aij element, here it is, or else this is a general formula we have. Now I require the minor of a11. So here it is, I will write here it is. So minor of a11 is equals to. So what is the minor of a11? So how to find the any element aij means how to find out what I told to you. So I should delete the ith row and jth column. But here I required a minor of a11. So minor of a11 means this element. I required the minor of this element. If you wanted to find the minor of this element means you should delete this row and this column. I mean, so a11 element where it lies, that row and that column we should delete, and next the remaining elements determinants we should consider. So deleting this row and this column, remaining elements determinant I should take. So what is the remaining elements? A22, A23, A32, A33. So this determinant I should consider. So simplify this determinant. How to find this determinant? This element into this element. A22, A33 minus of this element into this element. A32, A23. Clear? And next, my students, next I should consider minor of A12, minor of this element. Minor of A12 is equals to, again, so this element A12 where it lies, that row and that column we should delete. It means this row and this column I should delete, and remaining elements determinants I should take. What are the remaining elements? Determinant, here it is, A21, A23, A31, A33. So this determinant I should consider. So now solve this determinant. We already discussed how to calculate the determinant of the order to this element into this element. So A21 into A33 minus of this element into this element. A31, A23. This is the minor of A12. Next I will find out the minor of, here it is, minor of A13. For A13 means first row and third column. First row and third column. So this is also here it is. So first row, third column. It means again you should. I wanted to find this element minor I require. So if you wanted to find the minor of this element means first delete this row and this column. So remaining elements are A21, A22, A31, A32. So then we should consider the determinant of this. So determinant of this is equals to, here it is, A21 into A32 minus of A31 A22. This element into this element minus of. Excuse. So my dear friends, so these are all the minor of the element. Minor of A11 is this much. Minor of A12 is this much. Minor of A13 is this much. So what they asked you to find the minors and cofactors, and also just only I discussed how to find out the cofactor. So cofactor, now I will discuss here it is cofactor, here it is. So here it is cofactor. So cofactor of Aij, we know that. How to find the cofactor of Aij? So cofactor of Aij is equals to, here it is, minus 1 whole to the power I plus j into mij. Minor of Aij minus 1 whole to the power I plus j. This is the formula to find the cofactor. Now I require the cofactor of A11. So here it is cofactor of A11. So cofactor of A11 is equals to, what is that? Minus 1 whole to the power, the Aij means a minus 1 whole to the power I plus j. So it means minus 1 whole to the power 1 plus 1 ith row and jth column into mij. It means m11. Aij is the cofactor if required, means minus 1 whole to the power I plus j into a minor of ij. But here it is I required the cofactor of a11. So therefore minus 1 whole to the power 1 plus 1 into m11. Minor of m11. Minor of 1 element. First and first column element. So this is equals to. So minus 1 whole to the power 1 plus 1 means, my dear students, minus 1 whole to the power 1 plus 1 means 2. So minus 1 whole square is plus 1 into m11. What is m11? M11 is nothing but a22 a33 minus a32 a23. Like this you should write. This is the cofactor of a11. Similarly, I am going to write the remaining elements here. It is, that is cofactor of a12. So cofactor of a12 is equals to minus 1 whole to the power 1 plus 2 into minor of m12. And next here it is minus 1 whole to the power 3. So minus 1 whole to the power 3 means it's minus 1 only. Please remember, already I told to you. So what is the condition we have? So or else I told you earlier only. So we know that minus 1 whole to the power even number means it is plus 1. Minus 1 whole to the power odd number means it's minus 1. So very important result that I am using here. This. So minus 1 plus 2 is 3. Minus 1 whole to the power odd means it's minus 1. M12. So what is M12 here? It is M12 means already I calculated here. This. So minor, this is nothing but minor of A12 is nothing but M12. This is, you can call it as, this is M12, this is M11, this is M13. Minor of A13 is, this is nothing but M13. So here it is, M12 is, what is M12 my dear students? M12 is, here it is A21, A33 minus of A31, A23. Clear? And next my dear students, cofactor of. So here cofactor of a13. So cofactor of a13 is equals to, what is the formula here? It is minus 1 whole to the power 1 plus 3 into m13. So minor of m13. So minus 1, 3 plus 1 is 4. So minus 1 whole to the power 4 means even. Minus 1 whole to the power 1 means 1 into. So what is m13? M13 is here it is. So a21 a32 minus of a31 into a22. So this is the cofactor of a11, cofactor of a12, cofactor of a13. Clear? Now my dear students, you can observe here this. So if I solve means this is nothing but what I did in the earlier classes. It means if I wanted to calculate the, here it is, if I wanted to calculate the determinant value of this means. So what is the determinant value of this? So determinant of value of this, if you solve means this is nothing but here it is. So this is nothing but what happens here it is. So take the element along the row 1. So we already know how to calculate the along the row 1, how to calculate, how to solve the determinant. So first we should change the sign, plus, minus, plus. Clear? So if you solve means you will get here this. So what you will get here is plus a11 into, so leave this. Now up to here what I told to you, this is how to find the cofactor. This concept is finished. Just I am just solving. This is the another one part. So that both relation you will come to know later. Just I am going to discuss here it is. Now expand this, expanding along row 1. So normally we know how to, if I expand along row 1 means how to calculate, we know. So plus a11, that is nothing but determinant value. So a11 plus a11 into, leave this row and this column. So what is this here? This we should consider the determinant of remaining elements. So a11, leave this row and this column. So a22 into a33, a22 into a33 minus of a32 a23. Next minus of a12. So minus of a12. Again leave this row and this column. So remaining elements a21 into a33, a21 into a33 minus of, here it is A1 to leave this row and this column, A21 into A33 minus of A31 into A23, A31 into A23 plus of A13, A13. So what happens here? Leave this row and this column. So remaining elements is A21, A32 minus of A31, A22. So my dear students, this is what your required determinant value. So please don't be panic or don't confused. So just remember, here it is. Up to here what I told you, this is what all about the how to find the cofactor and minor. Now whatever I wrote with the black color, so that is just I expanding along the row 1. So we know this, how to calculate, how to solve the determinant value, that we know already. So just that I applied here it is. So what I told you, first change the sign. So plus minus plus I changed, and I usually by the regular method I solve this. Now you can see here, my dear students. Here you can observe, here it is. This is what your determinant value. So this can I write, here it is. This can I write, please observe, here it is A11, here it is A11 means this is the, so along the row 1 elements A11, A12, A13, A11, A12, A13. Clear? And next what I did, so here it is plus, here it is minus, and here it is plus. It means, my dear students, it means here it is. After that, this is what A22 minus A3. This is nothing but, here it is determinant value I calculated. So therefore, it is nothing but, if you consider along the row elements, along the any row or any column, if you consider the elements and along the any row or column elements, if you multiply with the cofactors, cofactor, here it is, and next it is second element, here it is A11 element, cofactor of A11. Next plus A12, cofactor of A12. Next plus A13, cofactor of A13. So my dear students, please remember, along any row or any column with the elements, if you multiply with the cofactor and if you add this, so this will gives you what it will give? It will gives you the determinant value only. So therefore, these cofactors and minors are useful to calculate the determinant value. And next we will use this concept, minors and cofactors, while calculating the adjoint or inverse of a matrix. In such cases we are going to use minor and cofactor concept here. Please remember, here it is what I told you, my students. We know up to here I calculated how to calculate the cofactor and minor. This is nothing but, if you wanted to find the determinant value means, so my students, you can observe, here it is cofactor of A11 is nothing but, here it is plus into, what is the, here it is A11 is first element I considered, A11 into, you can observe, here it is plus of A22, A33 minus of A32, A23. It means, here it is, to the first element I multiplied with the cofactor of A11. So what is the cofactor of A11? This is what your cofactor of A11. Next, I consider what is the cofactor of A12. Cofactor of A12 is negative, minus 1 into this much means minus of A21, A33 minus A31, A23. So here it is A12 to the A12 element, if you multiply with the cofactor of that element, and next my distance here to the third to this element A13, I multiplied with the cofactor of this corresponding element. So if you multiply and if to the any elements of the any row or column, if you multiply with the cofactor of the corresponding elements, and if you add, then that value will gives us the determinant value. So if you solve this matter, students, if this is nothing but the determinant value. Expanding along R1, we are getting the same thing. So therefore, please don't confuse, try to understand the concept. So what I am telling to you, if you wanted to find the determinant value means what should you do? So if you wanted to find the determinant value means, so to the any row or columns, to the any rows or columns of the elements, if you multiply with the corresponding cofactors, if you multiply with the corresponding cofactors and if you add, that value will gives you the determinant value. For example, whatever I told you, that result I am showing here it is. I am verifying in front of you. So what is that? So here it is, along R1 I am considering A11. To the A11 I multiplied with the cofactor of A11. Clear? And to the A12 element I multiplied with the cofactor of A12. To the element A13 I multiplied with cofactor of A13. So this is what? This is, if it is nothing but the determinant value after solving expanding along R1. Whatever value you will get, the same value. If you solve this one means you are getting the same value. Clear? So therefore what I am telling to you, whenever you wanted to find the determinant value means what should you do? To the elements of the any row or column, if you multiply with the corresponding cofactors and if you add, then that value will give us the determinant value. So therefore the result is, so what is the result you can frame here? The result I can frame is the sum of the products of the elements of the any row or column, if we multiply with the cofactor, if you multiply with the corresponding cofactors, then that will give us the determinant value. Whether that is giving or not, that I verified here. So just forget all things. Just I'm clarifying. I'll verify here. So what is that? First consider the one determinant. So to this determinant, I am solving along the R1, I mean row 1. So if I solve along the row 1 means whatever value I calculated, so this value, the same value you will get if you apply this, is if you consider the row 1 elements. So what is here? It is row 1 elements. To the row 1 elements, what are the row 1 elements? A11, A12, A13, A11, A12, A13. To this, if you multiply with cofactor of A11, so what is the cofactor of A11? Cofactor of A11, you can observe here, this cofactor of A11 is A22, A33 minus A32, A23. This is what you got here, it is. And next, consider the second element, so A12. To the A12 element, if you want to multiply with the cofactor of A12, so what is the cofactor of A12? Minus of A21, A33 minus of A31, A23. So this is what your cofactor of A12. So plus into minus, it is minus here it is. And next it is to this element A13, if you multiply with the cofactor of A13. So what is the cofactor of A13? So this is your cofactor of A13. Clear? So this both value will same you will get. The value will you will get the same. So therefore here it is, by using this concept minor and cofactor only I solved this one. It means, but only the difference is I discussed in the earlier classes to how to calculate it. Here it is, if the determinant is of the order 3 cross 3, but directly I told you in the earlier classes the method how I told you. So first in here it is, and even I told you that first you should change the sign, minus plus minus plus minus plus minus plus. So I told you that change the sign like this. This is I am changing sign because of this formula, minus 1 whole to the power 1 plus 1 minus 1 whole to the power 1 plus 2. So instead of telling cofactor and minor, directly I told you the result. So what I did here is, if I wanted to find the along row 1 means first I'll get this, I'll change the sign and I use this method. So if you calculate means this is what this is writing by using this cofactor and minor only. But in starting we didn't discuss that. Now I am discussing, but the procedure is same. Clear? So here I am introducing the name cofactor and here it is minor. But cofactor and minor we already used that. Even we solved the question also. but we didn't given the name in that cases. But now I given to you the names here. So this is what cofactor and here it is minor. So whatever I told to you, the method how to while solving the matrix of the determinant of the order 3 cross 3, thus that method is based on this cofactor and minor itself. Clear? So now my students, so just a verified here it is. So what is that? So in if you wanted to find the determinant value of the order 3 cross 3 means what should you do? You should consider it is any elements along any elements of the row or any elements of the column. To that you should multiply with the corresponding cofactor. If you multiply with the corresponding cofactor and if you add means that will gives you the determinant value. Clear? That's it. Very simple. And now additions. So what is the main concept we learned here? Is in the today's class the main concept we learned is how to find out the minor of the element. So minor of any element in the given determinant of aij is denoted by capital letter Mij, and it is calculated by deleting the if I wanted to find the a11 minor means, so I should delete the a11 element where it lies, that row and that column we should delete, and we should consider the determinant of the remaining elements. And if I wanted to find out the cofactor means minus 1 whole to the power I plus j into Mij. Like this you can calculate. Clear? So this is a very important concept, how to calculate minor and cofactor, that I discussed. And in the next video we are going to discuss some more examples and discuss, and then we will discuss the next concept. Clear? I hope you understood. Still if you have any doubts you can comment me, I reply for that. Thank you. Please pause the video to write it down. Up to here, write down this. My students, I think it's visible to you. Up to here, write down. So next we'll continue in the next class. Please pause the video to note it down. I'll give you some time.